This film has been prepared by the Environmental Protection Agency as a part of our continuing effort to assist laboratory personnel by augmenting the written procedures for new testing methods by videotape demonstrations. The subject of this film is the Toxicity Characteristic Leaching Procedure, or TCLP, SW846, method number 1311. This film will not only assist in training people to understand the TCLP procedure, but will hopefully clarify some of the more subtle points in the published method by visually demonstrating each important step. I'm Glenn Abbott. I will narrate the procedure, which will be demonstrated by analytical chemist Bill Charlton. The TCLP includes a step for preliminary determination of how the specific waste should be handled. The TCLP flowchart, which you now see on the screen, shows how several different paths may be taken in performing the procedure depending on these determinations. To demonstrate this fully, we will run different types of waste through the TCLP. As we do this, we will refer again to the flowchart to show which path is being followed. For performing the extraction, there are two different techniques depending on which contaminants are of interest. The bottle TCLP for metals, pesticides, herbicides, and semi-volatile organics, and the zero headspace extractor, or ZHE TCLP, for organic volatiles such as solvents. The flowchart illustrates how the procedure differs for liquid, solid, and multiphasic wastes. In simple terms, the difference is that wastes which are liquid or contain insignificant amounts of solid do not have to undergo extraction, and after filtration are ready to be analyzed. When testing wastes which contain no liquid, one can dispose with the initial liquid-solid separation step and go directly to the extraction. Multiphasic wastes, however, require both types of treatment. An additional step may be required if the initial liquid phase is not compatible with the liquid produced in the extraction. Here's a brief list of the apparatus which will be used during the demonstration. The glass fiber filter and the filtration apparatus which holds it. The borosilicate glass bottle to be used as a vessel for the extraction of non-volatiles. Two examples of the zero headspace extractor. These are both gas pressurized variety, but a mechanically pressurized version approved by EPA can also be used. Two different ZHE filtrate collection devices, the Tedlar bag and the glass syringe. A fluid transfer pump. The agitator, with which to rotate the extraction vessel in an end-over-end fashion at 30 plus or minus 2 RPM, and a typical laboratory balance, accurate to within 1/100th of a gram. We have on hand all the reagents which will be used to perform the TCLP. The reagent water has been monitored for impurities, and the other fluids are checked frequently to ensure their integrity.
First, a few guidelines for preparing and storing the samples. Do not add preservatives. Refrigeration is allowed unless it causes irreversible physical change in the waste, such as precipitation. Where samples are to be evaluated for volatile contaminants, particular care should be taken to minimize the loss of volatiles. All samples should be stored at 4 degrees C and for as little time as possible. See Chapter 10 of SW846 for up-to-date information on the maximum storage times allowable for specific contaminants. Collect and test at least 2 samples of the waste, 3 if volatiles are of concern.
We are ready to begin the TCLP preliminary determinations. For this purpose, the first of 3 samples of the waste will be used, a minimum of 100 grams. Bill will start by evaluating the percent solids of the waste. This is defined as that fraction of the total waste sample from which no liquid may be forced out by an applied pressure, as we will see. For our demonstration, we are using waste B.
If the waste will obviously yield no liquid when subjected to pressure filtration, that is 100% solids, this step and the one following it are unnecessary and may be skipped. That is why we put aside waste A.
But if the waste is liquid or multiphasic, then it must be filtered to separate the liquid and solid phases. We are going to see that filtration process in more detail when we do the extraction. So for now, we'll just go through it quickly. Pre-weigh the container which will receive the liquid filtrate. Assemble the filtration apparatus, placing a pre-weighed 0.7 micron glass fiber filter between the support screens and securing it. Weigh out at least 100 grams of the sample and record the actual amount. Let the slurry stand before filtration, allowing the solid phase to settle. Centrifugation can be used as an aid to filtration. Transfer the waste to the filter holder. If more than 1% of the waste adheres to the side of the transfer container, measure and subtract that amount from the waste being filtered. If the amount of the expressed liquid will be increased, allow the sample to warm to room temperature before filtration. Gradually apply 1 to 10 psi until the pressurizing gas moves through the filter. If in any 2-minute interval neither the gas nor liquid passes through the filter, increase the pressure in 10 psi increments to a maximum of 50 psi. Filtration is ended when the gas passes through the filter or when liquid flow has ceased at 50 psi. The filtrate is collected in the pre-weighed beaker. That beaker is now weighed again to determine the amount of filtrate which has been produced. The weight of the solid is determined by subtracting the weight of the liquid from the total weight of the waste as recorded before filtration. The percent solids can then be easily computed with this formula. Percent solids equal weight of solid divided by initial weight of waste multiplied by 100. If the waste sample obviously has a significant amount of solid material, as waste B did, the solid phase must be subjected to extraction. In that case, the next step is to determine whether the sample needs to undergo particle size reduction, followed by choosing which extraction fluid to use. Bill will demonstrate what to do if the sample appears to be composed almost entirely of liquid material. We'll determine the percent dry solids for waste C and D. Remove the solid phase and filter from the filtration device. Dry them at 100 degrees Celsius until 2 successive weighings yield the same value plus or minus 1% and record the final weight.
Recall that we pre-weighed the filter for use in the percent dry solids determination. Take care to ensure that flashing will not occur upon heating the solid. The use of a hood is recommended.
Calculate the percent dry solids with this formula. Percent dry solids equals weight of dry waste and filter minus weight of filter divided by initial weight of waste multiplied by 100. If the percent dry solids is less than 0.5%, then the waste does not need to undergo extraction. The waste after filtration is defined as the TCLP extract. In our demonstration, waste D meets that criterion. No other preliminary determinations are required for that waste, so proceed to the actual extractions. However, if the percent dry solids is greater than 0.5%, as it is for waste C, then extraction of the solid portion will be necessary. Go back to the beginning of the previous step and use a new representative sample to make the 2 remaining determinations. At this time, determine whether particle size reduction is necessary. If the surface area of the solid is greater or equal to 3.1 centimeters square per gram, as in filamentous waste such as rags and paper, or the solid is smaller than 1 centimeter in its narrowest dimension, particle size reduction is not required. Wastes which do not have a definite particle size, such as grease, will not have to undergo particle size reduction. Here, waste A is being passed through a 9.5 millimeter Teflon-coated standard sieve to show that it meets the requirement. If particle size reduction is necessary, it may be done by crushing, grinding, or cutting the solid to increase the surface area. The final determination that needs to be made is which extraction fluid should be used to leach the solid. This step is necessary when the solid content is greater than 0.5% and must therefore undergo extraction, and if non-volatiles are of interest. Note that TCLP extraction for volatiles requires use of only fluid number 1. The choice of fluid is based on the alkalinity of the solid. Weigh out a small subsample of the solid phase of the waste. Reduce particle size if necessary to less than 1 millimeter in diameter. Transfer 5 grams to a 500 milliliter Erlenmeyer flask and add to it 96.5 milliliters of reagent water. Cover and stir vigorously with a magnetic stirrer for 5 minutes. Measure and record the pH. If the pH is less than 5, use fluid number 1. If the pH is greater than 5, add 3.5 milliliters of 1 normal hydrochloric acid to the slurry. Briefly stir and cover. Heat the slurry to 50 degrees Celsius and maintain for 10 minutes. After the solution has cooled to room temperature, measure and record the pH again. If it is now less than 5, use fluid number 1. If the pH is still greater than 5, then the waste has a strong buffering capability and fluid number 2 should be used. The preliminary determinations are now complete. The samples used up to now are discarded. They are not used for the actual extractions. Referring again to the TCLP flowchart, each of our samples now has a clearly marked path to follow. We will review the examples to show how to proceed for each of them. Waste A was 100% solids, so it will not require initial filtration, but it will undergo extraction. Waste B was 50% solids, so it will need to undergo both initial filtration and extraction. Waste C was mostly liquid, but contained enough solid material to require extraction as well. We will now begin the demonstration of the bottled TCLP extraction for non-volatiles. The first step is to consider how much waste to filter. The method requires at least 100 grams, but if the waste has a low percent solids, that amount may not generate sufficient extract to perform all the necessary analysis. This is particularly a problem when the initial liquid phase is not miscible with the aqueous extract of the solid. Wastes, which are 100% solid, like waste A here, can be extracted without first separating the liquid and solid phases. Bearing in mind how much of these entirely solid wastes will be needed for extraction, weigh out at least 100 grams of sample and record the amount used. For all wastes containing free liquids, filtration is a necessary step. The pre-weighed filtrate collection container is placed under the assembled filtration apparatus. The glass fiber filter has been acid washed and distilled water rinsed prior to use to prevent the filter from contaminating the sample, since metals are of concern here. Place at least 100 grams of the sample into a pre-weighed container. The sample may require homogenization to assure that the subsample to be used is representative. Weigh the container again with the sample in it. Remember that wastes like D, which contain less than 0.5% solids, do not require extraction of those solids. That waste, after filtration, is defined as the TCLP extract. Be sure that the amount of waste is enough to support all the analysis. For wastes such as B and C, use the percent solids information to determine the optimum sample size. Slurries should be allowed to stand so that solid contents will settle. This will aid in the filtration process. Centrifugation is another useful aid. If it is used, decant and filter the liquid first, followed by filtration of the solid through the same apparatus. If more than 1% of the sample has adhered to the walls of the transfer container, measure the amount and subtract it from the sample weight to be filtered.
Be sure that the waste completely covers the surface of the glass fiber filter within the device. If the filter is not completely covered, the pressurizing gas will pass through the filter unobstructed, with the result that solid-liquid separation will not occur.
The top plate of the device is quickly put in place to prevent lateral leakage of the sample around the filter O-ring seal on the filtration unit. Once the device is fully assembled, gradually apply 1 to 10 psi of gas pressure to the apparatus to begin solid-liquid separation.
This is a crucial point in the process because increasing the pressure too quickly may cause the filter to clog.
Collect filtrate using 1 to 10 psi until the pressurizing gas passes through the filter, indicating that all liquid has been removed. If no additional liquid appears in any 2-minute interval, slowly increase the pressure in 10 psi increments to a maximum of 50 psi. Filtration is stopped if at any time the gas begins to move through the filter or when 2 minutes have elapsed at 50 psi with no additional liquid appearing. When filtration is ended, measure and record the volume of the filtrate and the weight of the beaker containing it. If the waste sample was 99.5% liquid, like our waste D, then extraction is unnecessary and the filtrate should be aliquoted for analysis. Otherwise, the liquid must be stored in a sealed refrigerated container for eventual combination with liquid which results from extraction. Recall that if the initial liquid phase is not water-soluble, then the two liquids will be analyzed separately and the results combined mathematically. Disassemble the filtration apparatus and remove whatever material is inside, along with the filter. That material is defined as the solid portion of the waste, and it will undergo TCLP extraction. If particle size reduction is necessary, it may be done at this time. When the particle size is sufficiently small, place the solid and the glass fiber filter in a borosilicate bottle. Borosilicate glass is recommended because other types of glass can cause contamination problems, especially for metals. The appropriate extraction fluid, as determined from the solid's alkalinity, is then added to the bottle. The amount of fluid used is equal to 20 times the weight of solid being extracted. Seal the extraction bottle with a Teflon-lined screw cap. Secure the cap to the bottle further with Teflon tape. Place the bottle in a rotary extractor. Rotate it in an end-over-end fashion at 30 plus or minus 2 RPM.
For some types of waste, pressure may build up within the bottle from gases evolving out of the extraction. Since volatiles are not of interest here, the bottle may be periodically vented to relieve the pressure.
The bottle continues tumbling for 18 hours. When the agitation period is complete, remove the bottle from the extractor. Allow the contents to settle, as they will have to undergo a final filtration. This filtration is conducted exactly as before, but with a new filter.
At this point in the procedure, since the object is to recover the liquid in the filtration device, but not the solids, it is allowable to replace a clogged filter with a new one. Acid washing the filter is again required if metallic contaminants are of concern.
In our demonstration, waste A contained 100% solids. Since it had no initial liquid phase, the filtered leachate equals the TCLP extract. Waste B contained an initial liquid phase, which can now be combined with the filtered leachate to form the TCLP extract. Waste C is an example of when the initial liquid phase is not miscible with the aqueous extract. For this waste, each of the two liquids are analyzed separately, and then results are combined in a simple volume-weighted average. Finally, waste D did not have any significant solids, so after initial filtration, it was placed aside while extraction was performed on the other wastes. Once the TCLP extract has been obtained, measure and record the pH. Samples should immediately be aliquoted for analysis. Before storing metallic aliquots, acidify them to a pH less than 2 with nitric acid. Other aliquots should be stored at 4 degrees Celsius until analyzed. Observe the storage time limit for specific analytes. Compare the contaminant concentrations to the thresholds listed in the appropriate regulations. Consult the method for quality assurance requirements. This concludes the section for non-volatiles referred to as the bottle TCLP. We will now demonstrate the zero headspace extractor, or ZHE TCLP. This is the procedure to use where volatiles are of concern. The ZHE should be used only for extracting volatiles and is unsuitable for non-volatile analytes. The ZHE has an internal capacity of about 500 milliliters, much less than the device used for the bottle TCLP. This means that it can hold only 25 grams of solid during extraction, due to the need to use 20 times that amount of extraction fluid. Once the ZHE has been charged with sample, it cannot be opened and refilled to obtain 25 grams of solid. The extraction must be run on whatever amount of solid less than 25 grams is in the ZHE. If that does not provide sufficient extract to support all the necessary analyses, then run multiple extractions of the waste and combine all the resulting extracts before taking aliquots. Although the ZHE TCLP allows for particle size reduction, it should be done to whatever degree possible during sample collection. In carrying out the following steps, do not expose the sample, the initial liquid phase, or the liquid extract to the atmosphere for any more time than is absolutely necessary. Before starting the procedure, determine what type of container will be used to collect the liquid filtrates. The two acceptable types are the Tedlar bag, which is often preferable because of its large capacity, and the gas-tight syringe. The syringe has the advantage of being reusable, but does not have sufficient volume to accommodate every type of waste. The method allows either for the glass syringe or the Tedlar bag to be used, but not both, unless the initial liquid phase and the aqueous extract are to be physically combined. If they are to be combined, only the Tedlar bag may be used.
The syringe can also be made of stainless steel. This type has several advantages over glass. It has a larger volume, usually 500 milliliters, and is unlikely to break. It also has a locking mechanism to keep the plunger from being forced out by high pressure. Whichever collection device is used should be evacuated and pre-weighed.
Partially assemble the ZHE by placing the piston inside the body. It will be useful to first moisten the O-rings with extraction fluid. Adjust the piston so that the volume inside the extractor is just sufficient to hold the amount of sample being used. Secure the bottom flange containing the gas inlet-outlet valve to the device. A 90mm glass fiber filter is placed between the stainless steel support screens. The filter screen assembly and the liquid inlet-outlet flange are set aside until they are ready to be used. Determine the sample size needed to charge the ZHE from the percent solids of the waste. If the waste is 100% solid, like our waste A, weigh a representative subsample up to 25 grams and record the exact amount. Many wastes, such as B here, have both liquid and solid phases in significant proportions. When the solids represent more than 5% of the wastes, use no more sample than is necessary to produce 25 grams of solid for the extraction. Use the formula weight equals 25 grams divided by percent solids multiplied by 100. In our example, B contains 50% solids, so we will charge the ZHE with 50 grams of sample to obtain 25 grams of the solid phase. For wastes like C containing less than 5% solids, use 500 milliliters automatically, filling the ZHE to its capacity. Because the percent solids is less than 5, that amount of sample will not exceed the 25-gram maximum for solids. The last case is a waste which is less than 0.5% dry solids, such as our example D. Since the amount of solid material in such wastes is too insignificant to require extraction, the initial filtrate will equal the TCLP extract. Be sure to filter enough liquid to support all the analyses required. Using the guidelines just explained, weigh out an appropriately sized representative subsample of the waste and record the weight. At this time, particle size reduction may be carried out if necessary. This may be achieved by any means that does not generate heat in and of itself. The sample and the appropriate reduction equipment should be refrigerated at 4 degrees Celsius, if possible, to avoid loss of volatiles.
Try to avoid exposing the sample to the atmosphere. Incidentally, the use of a sieve for measuring particle size is not recommended for volatiles. Instead, a graduated ruler may be used.
When the particle size is appropriately small, quickly transfer the entire sample, both liquid and solid phases, to the ZHE. It is not advisable to centrifuge wastes prior to filtration unless it can be accomplished in the original sample container. This avoids loss of volatiles due to repeated transfer. Secure the filter screen assembly to the top flange and place it on the ZHE body. Tighten all fittings on the device and place it in a vertical position. If more than 1% of the sample weight has adhered to the transfer container, measure and subtract it from the sample weight used. Attach a gas line to the gas inlet-outlet valve on the bottom flange. With the liquid valve open, begin to apply 1 to 10 psi or more if necessary, forcing all headspace out of the ZHE into a hood. At the first appearance of liquid, close the valve and discontinue pressure. If more liquid will be expressed, allow the sample to warm to room temperature. Wastes such as A, composed of 100% solids, do not require initial filtration. In these instances, slowly increase the pressure to 50 psi, then proceed to the addition of extraction fluid. For waste containing free liquids, initial filtration is a necessary step. Attach the pre-evacuated collection container to the liquid inlet-outlet valve. Open the valve and slowly apply 1 to 10 psi to force liquid out of the ZHE.
Some waste may filter more easily if the ZHE is turned upside down, causing the liquid and solid phases to trade places. For example, where the solid has a lower density than the liquid, it would float to the top and block the filter. This can be avoided by inverting the entire device.
Whenever no liquid has appeared in the collection container for a 2-minute interval, slowly increase pressure by 10 psi until 50 psi is reached. Filtration is stopped after no more liquid appears from the valve at 50 psi. Close the valves and discontinue pressure. Disconnect the filtrate collection container. The initial filtrate is to be handled as follows. If the original waste, like our example D, is less than 0.5% solids, the filtrate equals the TCLP extract and is ready to be aliquoted for analysis. For wastes like B and C that contain solids which will undergo extraction, store the initial liquid phase of the waste at 4 degrees Celsius under minimal headspace until it can either be recombined with the leachate of the solid if water soluble or be tested separately.
Some oily and paint wastes, which are obviously liquid, may remain inside the ZHE. If this occurs, carry them through the extraction as though they actually were solid.
The extraction fluid to use in ZHE TCLP is always fluid number 1. The leaching of volatiles has been shown to be unaffected by the pH of the leaching media. The amount to be added is 20 times the weight of the solid in the extractor. Use the following formula. Weight of fluid equals 20 times percent solids times weight of waste filtered divided by 100. With the ZHE again in a vertical position, attach a line from the fluid reservoir to the liquid inlet-outlet valve. The line shall be pre-flushed with fresh fluid to eliminate air bubbles. Release pressure at the gas inlet-outlet valve. Open the liquid inlet-outlet valve to add fluid to the ZHE using a direct transfer pump or similar means. Continue pumping fluid until the correct amount has been transferred.
The fluid is being drawn from a graduated cylinder reservoir to accurately determine when the right amount has been added. Various other fluid transfer techniques are allowed, including the use of a second ZHE.
When the correct amount of fluid has been transferred to the ZHE, check that all valves are closed and disconnect the fluid transfer line. Rotate the ZHE end over end 2 to 3 times to trap any gas remaining in the device at the top. With the liquid inlet-outlet valve again on top, slowly apply 5 to 10 psi behind the piston and carefully open the liquid inlet-outlet valve under a hood. This will bleed any headspace left in the device. Quickly close the valve at the first appearance of any liquid. Repressurize the ZHE with 5 to 10 psi and check all fittings to ensure that they are closed. Place the ZHE in the rotary extractor and rotate it at 30 plus or minus 2 RPM for 18 hours. Maintain ambient temperature in the room at 22 plus or minus 3 degrees Celsius. After the agitation is complete, check that there is still pressure behind the piston by quickly opening the gas inlet-outlet valve and noting any escaping gas. If the ZHE has leaked, see the method for the appropriate corrective action. When the problem has been solved, redo the extraction with a new sample of the waste. If the pressure was maintained in the ZHE during extraction, then the material in the extractor is ready once again for separation into liquid and solid phases. Remember that some wastes, like C, have an initial liquid phase that is not miscible with water. Do not combine those initial liquid phases with the liquid in the extractor. In our example, waste B had an initial liquid phase which should be physically combined with the leachate for analysis. The Tedlar bag, which already contains the initial filtrate of that waste, may also be used to collect the filtered leachate if there is sufficient volume.
Regardless of which collection device is used, all of the liquid in the extractor should be filtered and collected. An inline glass fiber filter may be used if it is suspected that the filter in the ZHE has been ruptured.
The leachate is to be treated as follows. If the original waste contained no liquid phase, the filtered leachate is defined as the TCLP extract. This was the case for our waste A. If the waste contained an initial liquid phase, like our B and C, the filtered leachate and the initial liquid phase are collectively defined as the TCLP extract. Recall that we put aside the initial liquid phase of our waste D because it contained no significant solids to be leached. It was itself defined as the TCLP extract. Each extract should immediately be aliquoted for analysis and stored with minimal headspace at 4 degrees Celsius.
Take care to not let the leachate become aerated as it enters the vol vial to prevent loss of volatiles.
If the individual phases are to be analyzed separately, the results will be combined mathematically using volume-weighted average, as shown in this formula. V1 C1 plus V2 C2 divided by V1 plus V2. After analysis, compare the contaminant concentrations to the thresholds listed in the appropriate regulations. This concludes the Zero Headspace Extractor TCLP protocol. There are a number of quality assurance practices to observe for both the ZHE and bottle versions of the TCLP. Maintain records of all data for inspection.
A blank should be run for every 10 extractions to check for possible contamination and to ensure that the equipment is functioning correctly.
After the extract has been produced, it is recommended that for every batch of up to 20 samples, a matrix spike be performed.
The purpose of the matrix spike is to monitor the analytical methods and to determine if matrix interferences are occurring in analyte detection.
The method of standard addition shall be used for each analyte if the recovery of the compound from the TCLP extract is not within 50 to 150% of the amount spiked.
Or if the analysis shows the contaminant concentration to be within 20% of the appropriate regulatory threshold.
In addition to what is mentioned here, follow all quality control measures outlined in the various analytical procedures.
Samples must be extracted and analyzed within the time limits published in the method.
This concludes the training film for the TCLP. If you still have questions, please contact the U.S. EPA Office of Solid Waste, 401 M Street, Southwest, WH562, Washington, D.C., 20460. Area code 202-382-4761.